In this video, we're going to be multiplying a polynomial by a monomial. The product rule for radicals: let the nth root of a and the nth root of b be real numbers, then in number 1, the nth root of a times the nth root of b is equal to the nth root of a times b. In number 2, c times the nth root of a times d times the nth root of b is equal to c times d times the nth root of a times the nth root of b, which is equal to c times d times the nth root of ab. The distributive property: if a times the quantity b plus or minus c is equal to a times b plus or minus a times c. In number 1, it wants us to multiply by filling in the steps below. Assume all variables represent positive real numbers. And in A, we have the square root of 2 times quantity square root of 3 plus square root of 5. And it wants us to apply the distributive property. So when we apply the distributive property, we're going to have the square root of 2 times the square root of 3 plus the square root of 2 times the square root of 5. And now it wants us to apply the product rule. So we have the square root of 2 times the square root of 3 is the square root of 6 plus the square root of 2 times the square root of 5 is the square root of 10. In B, we have the square root of 2 times the square root of 8 minus the square root of 75 minus the square root of 18 plus the square root of 3 plus 7. First thing they want us to do is simplify the terms in the parentheses. So we have the square root of 8 minus the square root of 75 minus the square root of 18 plus the square root of 3 plus 7. And that is equal to the square root of 8 could be written as the square root of 4 times the square root of 2 minus the square root of 75 can be written as the square root of 25 times the square root of 3 minus the square root of 18 can be written as the square root of 9 times the square root of 2. And then we have plus square root of 3 plus 7. And now I'm going to simplify. So I have the square root of 4 is equal to 2. So I have 2 square root of 2 minus the square root of 25 is 5. So 5 square root of 3 minus square root of 9 is 3. So we have 3 square root of 2 plus the square root of 3 plus 7. And now we want to combine our like terms. So we have 2 square root of 2 minus 3 square root of 2 is going to be negative square root of 2. And then we have negative 5 square root of 3 plus square root of 3 minus 4 square root of 3 plus 7. And now they want us to apply the distributive property. So now we're going to multiply this by the square root of 2. The square root of 2 times negative square root of 2 is equal to negative square root of 4 minus square root of 2 times 4 square root of 3 is 4 square root of 6, and square root of 2 times 7 is 7 square root of 2. And now we want to simplify. And the only term that's going to simplify is our square root of 4. So the square root of 4 can be written as 2. So we have negative 2 minus 4 square root of 6 plus 7 square root of 2. In C, we have 5 cube root of x times 3 plus 4 times the cube root of x squared. And the first thing they want us to do is apply the distributive property. So we'll have 5 cube root of x times 3 plus 5 cube root of x times 4 cube root of x squared. And now they want us to apply the product rule. So we have 5 times 3 is 15 times the cube root of x plus 5 times 4 is 20 times the cube root of x times the cube root of x squared, which is the cube root of x cubed. And now they want us to simplify each term. Now there's nothing in the first term that we can simplify. So 15 cube root of x comes down, plus we have 20. Now we have the cube root of x cubed, which is equal to x. In D, we have the square root of 5x times the square root of 5x plus 5x times the square root of 3y. And they want us to apply the distributive property. So this is equal to the square root of 5x times the square root of 5x plus the square root of 5x times 5x square root of 3y. And now they want us to apply the product rule. So we have the square root of 5x times the square root of 5x, which is the square root of 25x squared, plus the square root of 5x times 5x times the square root of 3y is equal to 5x times the square root of 5 times 3 is 15, xy. And now we want to simplify each term. So our first term, we have two perfect squares inside the square root, so 25x squared becomes 5x plus 5x square root of 15xy. There were no perfect squares inside this radical, so there was nothing to simplify in that term. Here in number 2, it wants us to multiply and simplify. Assume all variables represent positive real numbers. In A, we have 5x times 3y times 5x minus 3y. And the first step it wants us to do is multiply the monomials. So we have 5x times 3y is equal to 15xy times 5x minus 3y. And now it wants us to apply the distributive property. So we have 15xy times 5x minus 15xy times 3y. And now when we simplify, we're going to multiply 5 and 15 together, which gives us 75. And we have x times x, x squared, and a single factor of y, minus 15 times 3 is 45 times x, and we have two factors of y, so we have y squared. In B, we have the square root of 5x times the square root of 3y times the square root of 5x minus the square root of 3y. And the first step is to multiply the monomials. So we're going to have the square root of 5x times the square root of 3y, which gives us the square root of 15xy times the square root of 5x minus the square root of 3y. And now it wants us to apply the distributive property. So we have the square root of 15 times 5, which is 75. X times x is x squared, and y, minus the square root of 15 times 3 is 45, one factor of x, and we have two factors of y, so y squared. And now we want to simplify. So we can write 75 as 25 times 3, x squared y, minus the square root, and 45 can be written as 9 times 5, x y squared. And now we want to take all the perfect squares out of the square root. And the square root of 25 is 5. 3 is not a perfect square, it'll stay inside the radical. The square root of x squared is x, and y is not a perfect square either, so it's going to stay inside the radical with our 3, minus the square root of 9 is 3, and 5 and x are not perfect squares, so they stay in the radical. The square root of y squared is y, times the square root of 5x. In C, we have the square root of 5x times the square root of 5x times the square root of 5x minus 5x times the square root of 3y, and we want to multiply the monomials and simplify. So we have the square root of 5x times the square root of 5x is the square root of 25x squared times the square root of 5x minus 5x times the square root of 3y. And now we want to simplify the monomials that we multiplied together. So we have 25 and x squared are perfect squares. So we have 5x times the square root of 5x minus 5x times the square root of 3y. And now we want to apply the distributive property. So we have 5x times the square root of 5x minus 5x times 5x is 25x squared times the square root of 3y. And in D, we have the square root of xy times the square root of 16y plus the square root of 9x minus 2 times 4y square root of x plus 3x square root of y. And it wants us to apply the distributive property. So we have the square root of xy times the square root of 16y gives us the square root of 16xy squared plus the square root of xy times the square root of 9x gives us the square root of 9x squared y. Now, we have to make sure that this negative gets distributed to both of these terms as well. So we're going to multiply everything in the second set of parentheses by -2, not just 2. So we have minus 8y times the square root of x minus 6x times the square root of y. And now we want to simplify each term. So we have 16 is a perfect square and y squared is a perfect square. So we're going to have 4y times the square root of x plus 9 and x squared are perfect squares. So we have 3x times the square root of y minus 8y square root of x minus 6x square root of y. And now it wants us to combine like terms. So our like terms are 4y square root of x minus 8y square root of x gives us -4y square root of x. And we have 3x square root of y minus 6x square root of y. So we have 3 minus 6 is minus 3x square root of y. In 3, it wants us to rework the problem from 2D by first simplifying the radicals, the square root of 16y and the square root of 9x. So we're going to have the square root of xy times, now the square root of 16y can be written as 4 square root of y plus the square root of 9x can be written as 3 square root of x minus 2 times 4y square root of x plus 3x square root of y. And now we're going to distribute. So we have 4 times the square root of xy squared plus 3 times x squared y minus 8y square root x. And then we have negative 2 times 3x is negative 6x times the square root of y. And now we're going to simplify each term. So we have a perfect square, y squared, inside our first radical. So we're going to have 4y square root of x plus x squared is a perfect square. So the next term is going to be 3x square root of y minus 8y square root of x minus 6x square root of y. And now we can combine our like terms. So we have 4y square root of x minus 8y square root of x is negative 4y square root of x, and 3x square root of y minus 6x square root of y is minus 3x square root of y. And then it asks, is there any benefit in simplifying the radical first? And you can see that it took us 3 lines worth of work on both of these problems. So I'm going to say there's no benefit to simplifying the radicals first because it took us the same amount of steps. But if it helps you to simplify the radicals first, then because it took the same amount of steps, to me it's more of a preference than a necessity. And that's our video on multiplying a polynomial by a monomial.